Today we'll see the concept of stack. So before starting into a stack, so we have seen types of data structure. So which we have seen two types. One is linear, the other is non-linear. Okay. So under linear, we have seen like four different structures which follows the linear strategy. So what is linear? Linear is nothing but where you perform all ADT operations in a sequential way. So regarding linear data structure, we have array, we have array. So regarding linear data structures, we have seen the types as like array and then linked list, and the third one is stack, so which we are going to see today, and the last one is queue. Okay. So regarding stack, so we can just define that it's a linear data structure that follows a strategy called LIFO. LIFO or FILO. So LIFO means that last in first out. So which has been entered last, that is the first one to go out, because it is the stack, like it is a container which has only one end, okay, which has only one end to be performed, okay, which allows to perform, that is insertion, deletions, all your editing operations. So last in first out. That's where I just tell you like how it is working with. So here the working principle of stack is last in first out or FILO. FILO is nothing but the first in last out. Okay. So next, the stack, it has the important pointer called top, because we are going to perform all your ADT operation on the from only one end, because on the top only we are going to perform. So here the top is a pointer which is pointing to the topmost element of the stack. Okay, so whenever you add an element, so it is always adding to the top of the stack. Okay, and whenever you delete the element, it is deleted from top of the stack. So all you do ADT operation only from top of the stack. So here I can simply say that a stack is a container which can be performed the insertion and deletion from only one end, which is the top of the stack. So that's why we are maintaining a pointer called top. So when you're taking the working principle of a stack, okay, so we have already seen that it is last in first out. That is a working principle of stack. So here you can just see the figure which has been like given here. So we'll see like what is push, pop, all these things. Before starting with that, we'll see like how the stack will work. Okay, so as I told, it is a last in first out. Suppose if we want to store elements into the stack, this is my stack. If I want to store an elements into the stack, starting, just assume that your stack is empty. Okay, there is no element into the stack, so it is like it's an empty stack actually. So suppose if you want to store some elements into the stack, so here let's assume that the stack is empty initially. Okay, so we know that so we have some capacity of the stack, so just we can just have that stack either by implementing through array, or it can implement through linked list. So once you just implement through array, we know that the array is always mainly focusing upon a static memory. So in this case we'll be like focusing upon the stack capacity. So just assume that we have capacity of the stack is 3, so where which it can load 3 elements into the stack, and now initially the stack is empty, so we initialize the top pointer value to -1. So in this case, like the top is -1 means that it is invalid. Okay, the value is invalid for the array, to notify that there is nothing there in this stack. Okay, so to intimate that your stack is empty, my top value will be always -1. Okay, so so in this case, now starting I'm just going to push the value 1, which is I'm going to insert a value and single element into the stack. In this case I'm just giving so as it is only 3 elements, the capacity of the stack I have just given like this. So we have open in the top of the end of the stack, so where which I can just insert the element into the stack. Now you are inserting the element called 1, so now you are giving push 1, which means that I'm inserting 1 over here. In this case, once you like starting to insert an element into the stack, what we have to do is first and foremost you have to increment the top. Okay, so top should be incremented. So once you increment the top, okay, the top value initially, like when it is empty, it is -1, then it is like incremented and it becomes 0. So in the 0th position, I'm going to insert that value. Okay, so and then it'll be moving to the on the top. So next thing is like I'm going to insert the second element again to the top. So that's the same thing until your stack reaches the capacity limit. Okay, that is here we have given as three, right? Once it is reaches the 3 element, so here you can just observe here from top to bottom. Okay, from top to bottom, whenever we entering a new element, okay, the element is going from top to bottom like this actually. Okay, the last in. So now you see here, this is the one actually, and the 2 has been inserted on the top of the last inserted element. Now the last in is nothing but 2. Okay, now if I want to delete an element, we always know that we are going to delete the element from the top only. So now we can see that the last in element is 2. Again, if I want to take out, okay, do a deletion operation in the stack, then I'm just taking the 2 first, because I could not able to take 1 without taking 2, because 2 is on top 1. Okay, in this case, I'm just taking the 2 out. That's a case of LIFO, which means that lost in, which has been lost in, is 2, and the thing is like that is the one which is coming first. Okay, so here last in and first out, or else you can just say first in last out. So which has been entered first? The number 1 is the first element which has entered into the stack, that is the one which is coming out last. That is called first in last out. So that is a working principle of stack. Okay, so here in this case, whenever you perform an operations into the stack, okay, always you have to keep in mind that the stack will be working, I mean the principle of working principle of stack is LIFO or FILO. That is a pattern where you enter the value of the stack. So whenever you enter the value first, that will be the first, I mean first one to remove actually. Okay, so whichever enter first will remove last, whichever enter last will remove first. That is the case of working principle of stack. So by this we'll just wind up the video for basic working principle of stack. The next video we'll see that what is additive operations of stack and how to perform all the additive operations by implementing through array and linked list. Thank you.